Hello, my name is Nicole Nanka-Bruce, and this is my presentation on a pet care shop management system. My system is built on the case study of Brooks Pet Care, which is a pet care service shop located in Bristol, United Kingdom, which provides grooming and boarding services for small animals with primary focus on cats and dogs. Boarding services are services where people look after people's pets for a set period of time. Some of the grooming services include de-shedding, eye and ear checkups, and bathing. And for the boarding services, for which Brooks only offers 1 day boarding, customers can choose to opt for massages, swim, and exercise sessions in addition to their pet's boarding experience. Brooks Pet Care has recently adopted a BOPIS strategy, that is buy online, pick up in store, and would like a database system to manage the BOPIS system among other functionalities. By trying out the BOPIS system and becoming a dark store, which is essentially a brick and mortar location used to fulfill BOPIS functionality, it cuts off cost of expansion into a walk-in mart type store, increases customer interaction, and provides flexibility, security, and speedy transactions to their customers. Brooks requires this database system primarily for the following reasons: to efficiently monitor BOPIS inventory. This includes being able to view which products need restocking and when. To track and ensure smooth purchase from suppliers and track when products need to be cleared based on expiry. And Brooks uses a 45-day interval from the current date to the expiry date to determine the priority of clearing out. To track order placements and details, to identify which products are highly patronized or in high demand, to monitor pet boarding, and to keep track of service booking. Now, after our decomposition, our EER diagram ended up with 18 tables. The strong entities are customer, grooming service, pet boarding service, suppliers, products, employee ID, and kennel ID. And the weak entities are product order, pet, product order details, payments, pet boarding booking, and pet boarding log. For our specialization of the employee table, it is mandatory and disjoint, meaning an employee can either be a boarding worker, a grooming worker, or a manager, but cannot be both. Some of the enterprise rules among some of our most important table relationships include: a customer has 0 or more pets. A pet belongs to only one customer. A customer makes 0 or more product orders. A product order is made by only one customer. A customer makes 0 or more grooming service or pet boarding service bookings, and a grooming service or pet boarding service booking is made by only one customer. A grooming booking has only one payment. A payment belongs to 0 or 1 grooming booking. A pet boarding booking has only one payment, and a payment belongs to 0 or 1 pet boarding booking. A supplier belongs to 1 or more supplier products logs, and a supplier products log has only one supplier. I have assumed that full payments for any order or service must be made once. One boarding worker at a time looks after the pets, and multiple suppliers can supply the same products. In my logical table derivation, I came across a few instances where I could apply the rule of one-to-many binary relationship with the many side having mandatory participation, such as between customer and pet, grooming booking, product order, and pet boarding booking, and between pets and pet boarding log. As the rule directs, I put the customer ID as a foreign key in each of its corresponding related tables, and did the same with the pet ID, where I put it as a foreign key into the pet boarding log. I also had a one-to-one relationship with one side mandatory participation with all the tables that the payment table was connected to, and put payment ID as a foreign key in each of them. Now, moving on to my SQL code. The constraints I use in the creation of my tables of the database include default, check, on delete cascade, on update cascade, auto increment, and unique. The indexes that I created include 1 on the customer name and email, to make searching through the customer table, which has a potential to be large, quicker, for reasons such as contacting the customer about their order or pet. Another index was on the boarding date of the pet's boarding log, because in order to view which pets were or are being boarded on a particular day, there's going to be a search for the specified date. The next index was on the product name column of the product table to make searching by name faster, especially in cases where products have similar names. The last index was on the capacity of the kennels in ascending order. Since in queries involving the capacity and available spaces, the kennels with the smallest capacity would be likely to be filled first, and hence must be spotted first in the results of the query. After populating my database, I moved on to the queries. My first query seeks to assess which products are most patronized in percentage form. There is a right join to get all the products to include those that have never been ordered or purchased before as well. This goes to answer the requested functionality of being able to monitor this in order to inform stocking decisions. The next query provides the requested functionality of being able to check the details of each order, in order to reserve the required products for pickup. The where clause here searches for pickup dates that have not passed the current date yet, indicating that the customer has likely not picked up their order. The next query provides the requested functionality of being able to check to see which pet is being boarded on a particular day and who is watching them. The fourth query helps the admin or user to check for the available spaces within the kennels on a particular day, based on the requirement of being able to manage overbooking. The fifth query answers the first functionality of managing the BOPIS inventory by providing the opportunity to check the quantity of products left in stock. Finally, the last query answers the functionality of knowing when to clear products by checking to find which goods are closer to the expiry date. For this, as stated in the case study, Brooks uses a 45-day interval from the current date to the expiry date to determine which products have priority on the clearing out list, as I've done here with this where clause. Now to run the code. So as you can see, these are the results for each of the queries. This is the results for finding which product has been patronized the most. So here we can see that it's Duffy Shampoo and GC Puppy Food 1 kg with 30% each. And then here we have the details for each customer order that has not been picked up yet. Here we have the information on the pets being boarded on a particular day. And then here we have the information on the available spaces in each kennel on a particular day. And then here we have the stock quantity for each of the products that are in the inventory. And then here we have the products that are nearing their expiry date. Now to run it the second time for good measure, we see that it's giving us the exact same results without any hitches. Thank you very much for listening to my presentation.